do is we like to look at the inverse of 3 by 3 matrices. And then and there are a few different ways. We'll talk about it more later. But after we finding a way to find the inverse of a 3 by 3 matrix, we're going to use that, how we can apply that for a system of equation solving with 3 variables. So first, I want you to find the inverse of this 2 by 2 equations. What are we going to do? We can rewrite this, we can augment identity matrix. So here we get 2, 4, 3, 5, and then 1, 0, 0, 1. You see we attached second matrix into the first one here. So we got 2 by 4 matrix. Now what I want to do is I want to make the left side look just like the right side, meaning I want to convert the left side of the matrix into the identity matrix. Now, that means I want to make this 3 equal to 0. That would be my first step. So how am I going to do that? My first row, I'm going to multiply that by 3. My second row, I'm going to multiply that by 2, but I'm going to subtract it. Then what's going to be happening? My first row stays as it is, 2, 4, 1, 0. My second row now becomes 3 times of the first one is 6. Minus 2 times of 3 becomes 6, so both become 0. 3 times 4 becomes 12. Minus 2 times 5 becomes negative 10, so 12 minus 10 becomes 2. And then here 3 minus 0 becomes 3. And then 0 minus 2 becomes negative 2. And now what I want to do is I want to divide everything by 2, because so that I will have the denominator equal to, this number equal to 1. Then now what I'm getting is 2, 4, 1, 0. But I'll be getting 0, 1, 3 over 2, and then negative 1. Let's look at now first row. Now what I want to do is I want to make this number equal to 0, because that's how the identity matrix goes. Except the diagonals, all the other stuff has to be equal to 0. Now, in order for me to get this one equal to 0, I'm going to multiply. From the first row, I'm going to multiply the second row by 4 to match this 4, and I will subtract it. Since I'm working on the first row, my second row will stay as it is, 0, 1, 3 over 2, and negative 1. Now first value 2 minus 0 becomes 2. Second one is 4 minus 4 times of that, which still becomes a 0. Now this is 1 minus 4 times of that, which becomes negative 6. So hence we get negative 5. Now, lastly, what do I have here? 0 minus 4 times of that, so we get positive 4. And then what I need to do is I need to divide this side by 2. Then I'll be getting 1, 0, negative 5 over 2, and then 2. 0, 1, 3 over 2, and minus 1. So this is how we can figure out the inverse. So therefore we realize that inverse of original matrix, which was 2, 4, 3, 5, inverse of that is in fact equal to negative 5 over 2, 2, 3 over 2, and then negative 1. But if you remember yesterday, we came up with the formula of doing this one right away. Let's see if they matches or not. So we have 2, 4, I believe it was 2, 4, 3, 5. What I need to do was I need to find the determinant. What is the determinant? That's in fact these two, AD minus BC. So we get AD, which is equal to 10, minus the other two numbers, which is 12. So we get -2. So I know that inverse becomes 1 over -2. And these two numbers, what do? I'm going to swap them. So 5 here and then 2 here. The other two numbers, we're going to get negated. But when I distribute -1/2 here, then we get -5 over 2. And then 2, 3 over 2, and then -1. That becomes my final answer. And you can see that they are identical. But for the 3 by 3 matrix, there is a formula for us to do it, which requires for you to find determinant, which is a bit more complicated. And then we have to get something called transpose, and then a few other techniques, which we do not know them yet. But so we're not going to use the formulas to find the 3 by 3 matrices, but we will be using this method, which is the row operation. So now let's look at the next question here. Question is, find the inverse of this matrix. How would you do it? Now, so I'm going to write down the first one. 7, 2, 1, 0, 3, -1, -3, 4, -2. But I'm going to augment identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. I want to turn this one into this way. So that means use the triangle right over here in the middle, on the bottom. We call this one as a lower triangle. It has to be all canceled out to be 0. That means I want to get rid of this 3 first, or -3 first. How am I going to do it? I can get them by first row is multiplied by 3, and then third row is multiplied by 7, and then when I add them up, because they have different signs, then you know that this number will be canceled away. So numbers are a little bit now, ugly. So what we're going to be doing is, why don't we try to write down each row. And the only row that we're going to be working on is the last row. So first 2 rows, I'm going to leave them as they are. 7, 2, 1, and then 0, 3, -1. 1, 0, 0, 0, 1, 0. And then we're just going to write down the result of the bottom one here. So 3 times of the first row is what? 21. 6, and then 3, and 3, 0, 0. 7 times the bottom row becomes -21. 7 times of that becomes 28. 7 times of that, -14. And then 0, 0, 7. So when I add them up, these two become 0, of course. And those two becomes 34. And these two becomes -11. And then 3, 0, 7. Now, what I now need to do is I need to get rid of this number here, because this one is already 0, so we just have to get rid of this number. How am I going to get rid of this number? I cannot use the first row, because if I use the first row, it will make this 0 un-0 one more time. So therefore, I'm just going to use the second and third row. So second row here is multiplied by 34. Yeah, it's kind of a big number. And then in third row is multiplied by -3, and then add them up. So now, then, so we're going to get 34 times 3. So we get 0, 102, and -34, 0, 34, 0. Now -3 is multiplied to 34, so first one is a 0, -102, and +33. And then we get -9, and 0, negative 21. So I'm going to add up these two. Once again, we are working on the last row. So what I'm going to do is I'm going to copy down the first two rows as they are. 7, 2, 1, 1, 0, 0, 0, 3, negative 1, 0, 1, 0. When I add them up, I get a 0. When I add them up, I get a 0. When I add them up, I get negative 1. And then when I add them up, you get negative 9. Here I get 34. And then last one is negative 21. Now what I want to do is I want to multiply everything by positive 1. So that it will be 1, 0, 0, 1 here. Then I'm just gonna erase that here. So then this becomes a positive 1. This is positive 9. This is positive 21, while the middle one becomes negative. Now, the next one is, you see how I made a lower triangle equal to 0? Now, next thing that I want to do is I want to make this one equal to 0. So this will be part of making upper triangle equal to 0. How can I get rid of this one? By simply adding the last row to the second row. This one is actually simple. So I'm going to write down 7, 2, 1, 1, 0, 0. And then I'm going to write down the third row because we are working on the second row. 0, 0, 1, 9, negative 34, 21. So when I add up the second and third row, I get the 0, 3, and then 0, 9, negative 33, and then 21. But what I can do is I want to make this one equal to 1. So the way which we can do it is I can divide the second row by 3. Then I get 7, 2, 1, 1, 0, 0, 0, 1, 0, and 3, negative 11, and then 7. 0, 0, 1, 9, negative 34, 21. All right. Then let's look at the first row here. What I want to do is I want to get rid of this one equal to 0. After that, I want to get rid of this one equal to 0 first, 0 second. Then how can I get rid of this 1? I can subtract row 1 minus row 3. Then it will simply cancel away. Since I'm working on the first row, second and third row, I'm going to just write them down as it is. 0, 1, 0, 0, 0, 1, 3, negative 11, 7, 9, negative 34, 21. Then I get 7 when I add up first row minus the third row. 7 and 2 survive. 7 and 2 rather survive, and then becomes 0. Now 1 minus 9 becomes negative 8, becomes 34, and negative 21. Now, in order for me to get rid of this 2, R1 minus 2 times of R2, then I get to get rid of this one. Double of this value simply becomes 0, 2, 0, 6, negative 22, 14. So I'm going to add them up. So 0, 1, 0, 0, 0, 1, 3, negative 11, 7, 9, negative 34, 21. First one becomes 7 because I'm doing first row minus 2 times of this row. So second one is 2 minus 2 becomes 0. Third one is 0 minus 0 is equal to 0. And then the next one is what? 8. Negative 8 minus 6 becomes negative 14. And 34 minus negative 22 is 56. Lastly, I have negative 21 minus, so we get negative 35. And when I divide everything by 7, then I get 1, 0, 0, 0, 1, 0, 0, 0, 1, we get, divide everything by 7, then I get negative 2, 8, and then negative 5. And the other one, I'm just copying them. As you can see, it's not that simple. And then you may say, hey, this takes too long time. Yes, I do agree. But this is one of the ways which we can do at this point right now. So our original, matrix was 7, 2, 1, 0, 3, negative 1, negative 3, 4, negative 2. This, in fact, inverse of that is equal to negative 2, 8, negative 5, 3, negative 11, 7, 9, negative 34, 21. That becomes our answer. So this is what I'm expecting you guys to do for any time if I'm looking for inverse of a 3 by 3 matrix, and then if you are given that task by doing it by hand. Now, next question that which we're going to do is the application of this. You see, what I can do is, if I have to rewrite this one, I can rewrite this one as this way. 5, 7, 4, 3, negative 1, 3, 6, 7, 5. And then we have here x, y, z is equal to 1, 1, 1. So this is a matrix form of a system of equation. So if I want to just find that x, y, z, then that means I need to get rid of this one. In other words, if I call this one as A, this matrix as A, and then this capital X is a matrix of the variable. Let's call this one as a C as a result. Basically what I'm looking for is just X. I want to get rid of A. How will I do that? Since it's a multiplication, should I just divide by A? Yeah, but we cannot really divide in terms of matrix. If you understand division as the operation, opposite operation to the multiplication, our opposite operation of the multiplication would be multiplying by its inverse. So as long as we find out what inverse of this matrix is, we're gonna just figure out the x should be equal to inverse of A multiplied by C. Then bingo, that's how we can do it. This time what I'm going to do is I'm going to try to find the inverse of this matrix by hand. I mean using the calculator. So if you have calculator, I'm going to just call out the step and then try to go slowly. What I need you to do is I need you guys to follow with me with your calculator. First, I'm going to go for matrix. Matrix button is right above x to the negative 1 power, but it should be written in blue. So what I'm going to do is a second matrix, second, and then x to the negative 1. Now what I need to do is I need to input these values that I have, So in order for me to do that, I need to move to the right twice and then go to edit. And then I'm sure first one is the matrix called A. If you can just put on enter, so then you have two numbers. So a certain number, one number multiplied by another number. That's the dimension of the matrix that which you're looking at. So in this case, we are looking at 3 by 3. So I want you to type in 3 and then go for the next number as 3. Press enter. Then automatically it gives you the spot for 3 by 3 matrices with a whole bunch of zeros. So now what I want you to do, or even if you don't have zeros because you happen to use that before, that's fine. I need you to put each input value, each coefficient into each element of the matrix. Once you have done that, what I need you to do is I need you to second quit, come back to the home screen. And we want to find the inverse of the matrix A. How are we going to do that? Go back second matrix. And first column it says names. That's exactly what we want. So press 1 or matrix where you just plug in the values in. I want you to pull out that matrix. And in order for you to find the inverse, we just have to raise the matrix by negative 1 power. So we're going to have raised by -1 and press enter. Then you will realize that a to the -1 is 26, 7, -25, -3, -1, 3, -27, -7, and 26. So then x should be, I'm multiplying this matrix by the constant matrix, which is equal to one more, somehow it happened to be rather simple. So then it becomes 26, 7, -25. I'm just copying this one out and multiply that by the result, 1, 1, 1. Then what do I end up getting for the first one? These 3 multiply to these 3, so we get 8. Let's look at the second one. These 3 multiply to these 3, so we get -1. Lastly, what do we end up getting? If you have to add up these 3 values, multiplying these 3 values by 1, 1, 1, what we end up getting is -8. X, -1, -8. So that means we get to realize that x equals 8, y equals -1, and z equals -8. So that becomes our final answer for this question. All right, so with that one, I'm going to close up for today, and I'll see you later.